In this video, we will look at resistors in series and parallel circuit. How do we combine resistors connected in series and resistors connected in parallel? That is, we want to get the equivalent resistance of each of those combinations. In this first circuit, resistor R1 and R2 are connected in series. Therefore, the effective or equivalent resistance is just the sum of the two resistors. In the second circuit, R1 and R2 are connected in parallel. So the effective resistance is just 1 over R equal 1 over R1 plus 1 over R2. Or the effective resistance is R1 R2 divided by the sum of the two resistors. Now let's look at some numerical example. Let's say we have R1 6 ohm, R2 3 ohms. The effective resistance between A and B would be 6 plus 3, which is 9 ohms. So in the second circuit, the effective resistance between A and B and the resistance are connected in parallel would be 1 over R equal 1 over 6 plus 1 over 3. So this will be equal 3 over 6. So remember, you have to flip the reciprocal to get the actual effective resistance. R equals 6 over 3, which is 2 ohms. Next, we will look at a more complete circuit here with a battery as a power source of maybe 12 volt. So in this circuit, we are not going to do any calculation of current or voltage, but we want to try to determine the effective resistance in the circuit between A and B. First, we identify a pair of resistors that are either in parallel or series connection. Here, if you look at R2 and R3, these two resistors are connected in parallel. So let's call that R23. So that represents the effective resistance of the two resistors, 2 and 3, connected in parallel. And this circuit can be reduced to more simpler circuit below, where the R23 now represent the effective resistance of the parallel combination of R2 and R3. So next, we can see that the resistance R23 and R4 are actually connected in series. Okay, now let's call this R234 as the effective resistance of this combination, of this series combination. And we can further simplify the circuit to have R234 representing the effective resistance from the previous circuit. Now we can see that R1 is actually connected in parallel with R234. So we can get effective resistance between these two as R1234. And we are going to use the parallel combination formula to get the equivalent resistance. So we can write the final circuit as below. We have a 12 volt power source and Req, equivalent resistance or effective resistance for the whole circuit. Okay, let's put some of the calculation in the formula form. So the first one is the combination of R2 and R3 in parallel. So that would be R23 is equal to R2 R3 divided by R2 plus R3. Next, series combination of R23 and R4. So that would give R234 as the effective resistance, which is just R23 plus R4. So the next simplified circuit from that, we get the parallel combination of R1 and R234. And the R1234 is actually our equivalent resistance or our effective resistance for the circuit. Right, as you can see here, we finally have the original circuit maybe looks like quite complicated and has become a very simple one effective resistor circuit. So this is basically how we tackle, or how do we solve complex circuit like this in order to find the effective or equivalent resistance in a circuit. So what have we learned? Resistors in many circuits may be connected in both series and parallel. We need to determine what is the equivalent resistor or effective resistor in a circuit before we can find the total current through the circuit. This can be done by identifying a pair of resistors that are either in series or in parallel. And this one resistor left is called the effective or equivalent resistor in the circuit.